Hello everyone, welcome to IMS Gate Academy. In today's session, I will be discussing theory of machine, most important questions for your GATE 2024 examination. So only few days are left. So in this particular session, we will be giving the final touch to our preparation, and with these questions, you can expect similar kind of questions in your GATE examination. Right. So let's get started everyone in this session. But before that, please join this Telegram group, because all of the PDF of these sessions you will be getting in this Telegram group. Apart from that, latest job notification and as well as daily quizzes will be there for your technical exam preparations. Okay. And next is regarding the online live program, in which we are having more than 800 hours of sessions. Apart from that, theory book, exercise book and the PYQ book. Okay, all these you will be getting apart from the online live classes. And most important feature is 12 mentorship sessions, where the faculty will be with you always, and he will guide you, supervise you throughout your GATE preparation part. And 24/7 doubt solving portal is available with you. Whenever you will face challenge in the numericals, you will directly post your doubts in the doubt solving portal. Right. Now, so we'll start the session with the very first problem from the simple mechanism chapter. Right. So I will give you 2 minutes for this particular problem, and expect you will be easily able to solve this question as well. So this is direct formula based question, right? So everyone, let's start it and tell me your answers. Start solving this question first. Very good evening, Thirumala. Very good evening. So this question is from simple mechanism, right? And they're asking the ratio of maximum velocity during return and forward motion. So there is a direct formula, okay? There is a direct formula through which we can calculate this ratio. So see, in the examination, formulas and the relations are very important. So please try to revise your subject through your formula sheets that you have created, because in the last, the formulas and the relations are required to solve any particular given numerical. Okay. Last 1 second, 1 minute it is there left for you. Please, everyone, attempt this question and tell me your answers. Okay. Mention your answer in the chat box. Last 30 seconds left. Maximum velocity during return divided by maximum velocity during forward motion. During forward motion, okay, ratio of return to forward motion. This ratio they are asking directly. Anyone got the answer? Lord Ram says, Money says 1. Okay, let us check. There is a direct relation. If you remember this relation, C plus R, you would have solved this question very easily within seconds only. Now in this question, what is C? What is R? C is the distance between the fixed centers. Now actually in crank slotted lever bar mechanism, distance between the fixed center is nothing but the connecting rod. Let me show you here. So let's suppose this is what you are having as two fixed centers. So distance between two fixed centers is nothing but here connecting rod. Right, distance between the fixed centers is connecting rod. So directly in the question they have given the length of the connecting rod. C value is given as 200 mm. and crank radius they have given us 100 mm. So now these values we need to just put it into this formula here and you will get the answer very easily, right? So C value 200, 200 plus 100 becomes 300 divided by 200 minus 100. So what is the answer here? 3. Answer will be 3. Money answer will be 3. Okay. So this relation is very, very important for your GATE examination. So please try to remember this formula, and this formula is applicable for crank slotted quick return motion mechanism. Remember this part, crank slotted lever type quick return motion mechanism. For that one only this relation is valid. C plus R divided by C minus R. C is the distance between fixed centers. Distance between fixed centers is nothing but the connecting rod, and R is our crank radius, right? So okay, now next we'll move on to the next problem here. This question is from the gear train. Now this is very, very good question here, and I'm expecting you'll be able to solve. Let us just start the timer here first. Okay, and we'll be solving this question with relative velocity method only. 3 minutes I am giving you for this particular question. Okay, just try to solve this one. Using relative velocity method only we are going to solve all the problems that we have discussed so far in various sessions, in the live class, in the offline class, everywhere. I've told you this point. Many times I've told you this point. Relative velocity method will be using for epicyclic gate train problems. Okay, instead of tabular method that usually we will use in our college. But for competitive examinations like GATE or ISRO or BARC, wherever you are appearing, always use relative velocity method to solve the gate train problems, right? So read the question also very carefully. In the question itself they have mentioned P and C is a compound gears. So this gear P and this gear C is a compound gear. Compound gear means speed of rotation of P and C will remain same, right? And number of teeth for gear S they have given, P and C also they have given. They are asking the ratio of speed of gear S and gear D. So question is ratio of speed of S divided by ratio of speed of gear D. This is what they are asking. Okay, everyone should try this problem. Last 30 seconds. Okay, let us solve this question first. Ratio of NS by ND they are asking. Okay, so how we will proceed in this problem? Okay, first of all, see, as I told you, relative velocity method we will be using, right? So let us write speed of gear P with respect to arm divided by speed of gear A with respect to arm. It can be written as it is a case of internal gearing, so positive sign will be coming TA by TP, right? Now similarly I can write for speed of gear D with respect to arm divided by speed of gear C with respect to arm. Again, if you observe gear C and D internal gearing, so positive sign will come TC by TD, right? Clear? So P with respect to arm divided by NA with respect to arm, and in the question itself they have given A to be fixed, so speed of rotation of gear A will be 0 here. Now if I multiply these two equations, okay, from these two equations if I multiply, so this is our first equation, this is equation 2. So from 1 and 2, from 1 and 2 I can write direct relation here, okay, if I just multiply both the relations. So remember one thing, P with respect to arm and C with respect to arm. P and C is a compound gear train. When I will multiply these two things, so this numerator and this denominators are same, it will get cancelled out. So I am multiplying equation 1 and 2. So in the numerator we will have D with respect to arm, and in the denominator A with respect to arm. So we will be having D with respect to arm in the numerator divided by speed of gear A with respect to arm in the denominator. In numerator D and in the denominator A. Now both the sides will get multiplied, TA by TP multiplied by TC by TD. Okay. Now the main thing is we don't have the value of number of teeth A and number of teeth on D. So let us write the number of teeth A and D. Okay. Now please check how you will write number of teeth on gear A. See, from the geometry I can write radius of gear A can be written as twice of radius of gear P plus twice of radius of gear P is this much plus radius of S. Right. Okay. Radius of gear A can be written as twice of radius of P plus radius of gear S. So radius of gear A will be written as MTA by 2, and here it will be written as MTP by 2 plus MTS by 2. Now remember this point everyone. So module will remain same because as the pitch circle in the question itself they have given this thing, right? Having same pitch they have mentioned, so module will also be remain same. Okay. Basically again one more thing, if you see gear this thing part, gear P and A are what meshing with each other, then P and S are meshing with each other, right? So module has to be what remain same. Now module will get cancelled out, so TA equals to twice of TP plus TS. Now TA value, now just check what is TP value they have given. TP value is 30, 2 into 30 plus TS value, what is TS value? 24. So 2 into 30 60, and TA value you will be getting as 84. So this is the number of teeth on gear A. Now in order to calculate number of teeth on gear D, so radius of gear D, how I will write? See, radius of gear D will be written as radius of gear C plus radius of gear P plus radius of gear S. Clear? Radius of gear C, then radius of gear P, then radius of gear S. If I add all three radius, what I will be getting? Radius of gear D. So finally radius of gear D, MT into D divided by 2 equals to MTC by 2 plus MTP by 2 plus MTS by 2, like this. Now finally we will have this relation TD equals to TC plus TP plus TS. So if I write all those values here, finally TC value, okay, what is TC value? Let us check. TC value given as 18 plus number of teeth on gear P, it is mentioned as 30, and number of teeth on gear S is 24. So if you add this thing, it will be 54. 54 plus 18 will be having 72. Okay, right? Is that clear? 72 it will be there. So 3 plus 4, 5. Yes, correct. 72 it is there. Now, one more thing. This TD value we have calculated, TA value we have calculated. So what we will do here, just now we have written this relation, na? So this relation I will be using. So let us write it as equation number 3. Let us write this as a equation number 3. So from equation 3, so ND minus N arm divided by speed of rotation of A minus N arm equals to, because see, very important point, D with respect to arm can be written as ND minus N arm. Speed of rotation of A with respect to arm can be written as speed of gear A minus speed of arm, like that. So TA by TP, what is TA value? TA value is 84. TP value, okay, let us check. TP value is what? 30. TA by TP and TC by TD. TC by TD. TC value is 18 and TD value is 72. Right? Correct. So this is there. Okay. Now, on the left side, if I divide and basically on the left side, if I divide speed of arm, basically speed of arm from the numerator as well as denominator. If I divide from numerator and denominator speed of arm, so what I will be getting? Like this. And here, as speed of rotation of gear A is 0, so it will remain 0, and here it is 1. Are you getting this point? So what I have done in this particular problem, on the left side of this equation, I have divided the speed of arm. So speed of arm, here it will become 1, here ND by N arm will be there, 0 minus 1, like this. Okay, now you can easily solve this one and you will get the value of speed of gear D divided by speed of arm. You will get this ratio very easily. Okay, just solve this one. This ratio you should solve and tell me final value. D divided by arm. Speed of rotation of D divided by speed of rotation of arm. This ratio you need to tell me fast. Everyone, do it fast everyone, this value, and tell me your answers. And remember, we need to calculate NS by ND. In the question, we need to calculate NS by ND. Tell me your answers. See, this answer approximately is coming 0.7 and this answer you will be having is 0.3. ND divided by N arm. Now, what I will do here, see, gear S and gear P, okay, this is the one relation. S and P are meshing, okay, S and P are under meshing condition, okay. S and P are under meshing condition, then C and D are also meshing condition. Okay, so let us write the relation. Speed of rotation of S with respect to arm. Speed of rotation of S is meshing with gear P. P with respect to arm. So external meshing, so TP by TS. Another relation we have is speed of rotation of gear C with respect to arm divided by speed of rotation of gear D with respect to arm. So again, internal meshing it will be there, so TD by TC. So let us check C and D, internal meshing, so positive sign will be coming. So C and D, internal meshing, so positive sign, but P and S, if you check P and S, external meshing, so negative sign will come. Now, clear everyone till this point, everyone? Now, see. So if I multiplied, so what is that equation last we have written? So equation number 3, and let's suppose this is equation number 4. Now let us write this as equation 5 and equation 6. So from 5 and 6, if I multiply both this equation, P with respect to arm and C with respect to arm will get cancelled out, because P and C compound gears. So NS with respect to arm divided by ND with respect to arm equals to minus TP by TS multiplied by TD by TC. Right? Now just we will expand this NS minus N arm divided by ND minus N arm. Okay, what is the value of TP? TP value is 30 with minus sign multiplied by TD. TD we have solved 72 divided by TS value. TS value is 24 and TC value was 18, like this. Now, okay, so what we'll do here, just we'll write it here. Again we will simplify. So when again same thing what I will do here. On the left side I will divide numerator and denominator by speed of arm. Numerator and denominator I will divide with speed of arm. Right. ND by N arm already have solved. What is that value? 0.3. ND by N arm I have already solved. And from here I will be getting the answer. Okay. I will get the answer of NS by N arm. It is 0.3 minus 1. Okay. So we'll be getting the answer. So let us solve this one. You will get the answer NS by N arm finally. This ratio will be getting. Okay. So please everyone mention Shreya, how to write the formula. Okay. I will tell you how to write down these formulas. Relative velocity basic concepts is there. Okay. I will tell you. But please everyone solve this part. What is this answer? After simplifying this 30 into 72 divided by 24 into 18, what answer you are getting? Please mention in the chat box. Shreya, after solving this question, I will tell you how to write the relative velocity ratios in epicyclic gate train. So don't worry about that. Just let me know about this simplification, how you will solve and what answer you are getting for this one. Okay, so if you simplify this part, this is coming around minus 5, okay, minus 5, and if you solve this ratio, you will be getting 4.5. Now, what was this? 0.3, okay. So 5, 6, and then finally we will have this as equation 7. Now, what I will do here, ND by N arm 0.4, equation number 4, and this is 7. So if I divide 7 divided by 4, so what actually I am doing, NS divided by N arm divided by ND divided by N arm. So 4.5 divided by 0.3. If you solve, you will be getting 15 as the answer. 15 you are getting. Thank you, Mani. So this is a very good question actually. So far, whatever questions we have solved in our GSB also, in previous sessions also, even in, if you look at the PYQ questions also, those are like very easy, but this one is little bit lengthy actually. Okay, it is little bit lengthy. If you see all previous year question, they are like completed within 3 to 4 steps only, but it is taking more time. Now, so finally answer, please everyone confirm that 15 answer you are getting na. Just please confirm this part. So because ns by n arm was 4.5 and nd by n arm was 0.3. Right, okay, 15. Now Shreya, just look at here. I will tell you regarding how to write velocity ratio. Very simple thing I am telling you. Simple case. Let us take a very simple case. From that you can understand everything. Okay, let us suppose this is gear A, this is gear B, and this is arm. Right? Now, how to write relative velocity ratios? Very basic example. So, I need to look at the gears which are under direct meshing. Okay, which are under direct meshing. So, gear A and B are under direct meshing. So, I can write speed of gear A. Always relative velocity I will be writing. Speed of gear A with respect to arm. It means I am observing the rotation of A with respect to arm. I am sitting on arm and observing gear A. So speed of gear A with respect to arm, right? This is what I am writing. So how you will write this thing? Speed of gear A minus speed of arm. So let us suppose if I have to write speed of gear B with respect to arm. So I will be writing speed of gear B minus speed of arm, not gear, speed of arm. Simple. Now what I will do here, I know A and B under direct meshing. I will take the ratio speed of A with respect to arm divided by speed of B with respect to arm. So A and B under direct meshing, so this ratio will be equals to TB divided by TA, but the negative sign will be coming because of external meshing. Because of external meshing, the sign negative will be coming because sense of rotation will be different for external meshing. So this ratio you can directly write for A and B. A and B direct meshing. So directly I will write this relation. So to expand this relation, what I will write? Speed of A minus speed of arm divided by speed of B minus speed of arm. So minus TB by TA. Now one of the parameters they will be asking from this one. So such type of question you can solve within seconds from this relative velocity ratio. With this relative velocity concept method, this kind of question already has been asked in PYQ 2 to 3 times. This kind of question you can solve within seconds. So we need to directly write this relation. So always you need to look for the gears which are under direct meshing. Okay, which are under direct meshing, and always we will be taking relative velocity with respect to always arm. With respect to arm we will be writing. Now in the question that I have given to you, from here try to understand. Gear A and gear P direct meshing. Gear A, this gear A and gear P are direct meshing. Gear A is an internal gear. Gear A is an internal gear. Okay, gear P is an external gear. So meshing between gear A and P is internal meshing. So sense of rotation will be same in both the cases. So positive sign will be coming. Now I told you na, gear A, this gear A and gear P, direct meshing is happening, internal meshing. So for that, how I will write relative velocity ratio? P with respect to arm divided by A with respect to arm. Now number of teeth on gear A divided by number of teeth on gear P. This relation. Now C and D. This is our gear C. Gear C, and this is what gear D. Again gear C and gear D meshing. How I will write? Gears D with respect to arm, gear C with respect to arm. Ratio TC by TD. Both have positive sign because both are having internal meshing. So like this I will be writing ratios. Now if I multiply equation 1 and 2, this P with respect to arm and C with respect to arm gets cancelled out. Why? Because P and C is a compound gear. Compound gear basically means speed of rotation will remain same. P and C is a compound gear, so that's why speed of rotation same. So whenever I will multiply these two equations, numerator and denominator as it is same, it will get cancelled out. Shreya, is it clear? How to write the ratios? If it is clear, so then we can move to the next one. Clear, everyone? So this is a very important question, I'm telling you guys. This is very important. So we'll be writing relative velocity ratios and we will look at the unknown value. That is what they are asking. We will write all possible ratios. Okay, and after that simple mathematics we need to apply. So unknown was, in the question, unknown was this NS by ND. I need to figure out NS by ND. So whatever velocity ratios are possible, I will write and then I will use basic mathematics to calculate this ratio. Okay. So I hope it is clear. So final answer was 15 here. Now we will move to the next problem. Yes, very important, vibration. So let me give you the time here again. Start, everyone. Okay, read the question very carefully, guys. Most of the time you are doing mistake, okay, in interpreting the question data only. Each and every word of the question is what very important, and by mistake we have misunderstood the data or the information given in the question, then definitely will not be able to calculate the correct answer. Last 10 seconds. Okay, now look at the question here very carefully. A machine part having mass 2 kg. First of all, I will write down the data here. In a viscous, vibrates 2 kg mass and vibrates in a viscous medium. Okay, determine the damping coefficient. So basically they are asking the value of C. Okay, when a harmonic exciting force of 20 Newton, so F value is 20 Newton, that is acting, results in resonant amplitude. Okay, amplitude is 12 mm, but the main thing is this is not a case of normal amplitude, it is a case of resonant amplitude. Obviously it will be happening under the resonance condition. It will be happening under resonance condition, right? With a time period of 0.2 second. Now first of all, at resonance, omega equals to omega n. Omega equals to omega n, and here it is a damping provided. So amplitude of vibration will be what? Amplitude of vibration will be this one. So the formulas at least we need to remember. Okay, we need to remember the formulas, right? Amplitude of vibration will be F divided by K divided by 1 by 2, 2 into damping factor. Actually, Mani, you are writing magnification factor, which is 1 by 2 psi for resonance condition. For resonance condition, this is the magnification factor. But what is magnification factor? Nidhi, very good afternoon. Magnification factor is what? Amplitude divided by the static deflection. Na? Magnification factor value is what? Amplitude divided by the static deflection. Are you getting the point? So at resonance, omega equals to omega and magnification factor 1 divided by 2 into damping factor. So now this amplitude is what given? 12 mm. Fine. Okay, damping coefficient we can easily solve if we know the value of damping ratio. Damping coefficient C value we can solve, but for that damping factor or damping ratio we should know. But again the problem is stiffness is not given. The problem is stiffness is not given. So how to solve it? See, they have given this information 12 mm with a period of 0.2 second. Now at resonance omega equals to omega n, right? So let me write it in the next page here itself. So omega value can be written as 2 pi by t so 2 will get cancelled out, it will become 31.4 radian per second. So this is what omega or omega n as well, because omega equals to omega n under resonance condition, which can be written as under root k by m. Standard formula we are having, this is 31.4, under root k value we need to calculate. What is the mass they have given? 2 kg. From here we should get the answer of stiffness. Please everyone fast calculate the answer of stiffness here. Everyone. What is the answer of stiffness? Omega we calculated, omega equals to omega n, so omega n equals to under root k by m. You should get the answer of stiffness here fast. Everyone. Do the calculation and tell me your answer. Stiffness value. What is the stiffness value you are getting? Shreya, that formula you need to know, na? See, correct. Your amplitude formula is what? F naught or F simply I can write. This formula, I think you are talking about this formula. Shreya, I think you are talking about this formula, right? Yes or no, please mention here. Okay, got it. So, see, resonance means what? Omega equals to omega n. At resonance, omega equals to omega n, which means R value is what? 1. See, we need to remember this formula only. We need to remember this formula. R value 1. So, R value 1, this becomes 0. So, your amplitude of vibration becomes what? F naught by K divided by under root 2 psi R whole square, and then under root is there. So, square will cancel out with the under root. So, you will be having this thing only. this F naught by K is what? Your static deflection. Amplitude divided by static deflection is what? Your magnification factor. No, Shreya, that is the transmissibility ratio. Okay, I got your confusion. See, that is transmissibility ratio. Okay, let me write it here. Force transmitted divided by the force applied. I think you're talking about this formula, Shreya. This formula is for transmissibility ratio. It is different from the magnification factor. Don't confuse between these two formulas. This is your transmissibility ratio, and if I have to write magnification factor, okay, which is nothing but the amplitude divided by the static deflection F naught by K equals to 1 by, both will have a same denominators actually. Both are separate things. Shreya, I think your doubt is clear now. This is transmissibility ratio, this is magnification factor. Both are separate things. In transmissibility ratio, we are calculating ratio of force transmitted to the ground divided by the force applied to the system. And this ratio, what actually tells? It tells the performance of your vibrating isolation material. This ratio, transmissibility ratio, and this magnification factor, both are different things. Don't confuse between these two formulas. I hope now it is clear. Right, so transmissibility ratio will be using in those formulas in which they are asking the calculate the force transmitted to the ground. See, there is some machine we will have. This is some machine, and here I am using some vibration isolation system. Actually, vibration isolation system comprises of what? Spring and dampers. We will check the performance of this vibration isolation system. How much force is now transmitted to the ground, and comparing that value with the force applied. So that is what calculated using this part, transmissibility ratio. Clear? Okay, great. So see, there are actually so many formulas, but we need to know what are the meaning of each and every formula, and where are those formulas, what are the application of those formulas. So always remember, when we try to revise the formulas, we should understand what is the application of that formula, where it is used. Okay, what are the application part, that we need to remember at the same time. Don't just mug up all the formulas. We need to remember the application also, where we are actually using those formulas. Okay, yes, but no one, okay, please tell me the value of stiffness. Why? What are other peoples are doing? Stiffness value, who will tell? You need to solve this one and tell me what is the stiffness value. Stiffness value 31.4 equals to under root K by 2. What is the stiffness answer here? Spring stiffness answer. We have solved omega, then omega equals to omega, and this value we have put, and then stiffness we need to calculate, right? So that is what very easy calculation. I don't know why you are taking so much time here. Vinay Kumar, yes Vinay, correct, your answer is correct. 1971, 197192, no, 1971.92 it is there. Let me check also first. Yes, your answer is correct, but decimal you have not put here. Yes Vinay, your answer is correct, 1971.92. The stiffness we got finally. Now we will use our formula, this one. What was the amplitude given in this question? 12 mm. So please remember, we have to use the SI unit. So I will convert 12 mm into meters. What was the force here? Force was 20 Newton. 20 divided by 1971.92 divided by 2 into damping factor. This damping factor we are able to calculate after this one. So do let me know about this answer, everyone. Damping factor, finally your answer. Final answer of damping factor, everyone. The final answer here is 0.4225. So please cross check your answers. And then how we'll get damping coefficient, because damping factor is C by Cc. So it can be, critical damping coefficient can be written as 2 into under root K into M. K stiffness we know, mass also we know, and damping coefficient also we can calculate from here very easily. Right? Now damping factor value is 0.4225. 0.4225. Okay, please cross check your answers. And finally this answer is 53.06 Newton second per meter. Done. Okay, please cross check your answers. Then we'll move to the next problem. We'll move to the next problem, guys, after that. Okay, correct, Vinay? Done. Okay, we'll move to the next one. Yes, this one. Start solving this one. So let me give you the time also here. Okay, we have to work on the speed as well, guys. Speed also we need to improve here. Again, the question is from like if I talk about the formula used, same formula we have to use, amplitude of vibration. But in this case, they are asking the damping ratio. Amplitude of steady state vibration they have given. So same formula we have to use here. But calculation is little bit lengthy, no doubt. Okay, now just look at the solution here, how we will solve this question. 110 is the mass they have given. So first of all the data we should write it separately. Okay, mounted on elastic foundation having a stiffness this much, 2 into 10 to the power 6, operating at 150, omega value they have given 150 radian per second. Right, subjected to harmonic force, so force value also given 1500 Newton. Right, the steady state amplitude they have given, okay fine, 1.9 m. What is the damping ratio? So they are asking the damping ratio value. Now direct formula based question, but yes, calculation is lengthy here. Now see, R is the ratio of omega by omega n. Omega already they have given 150, but how to get omega n? Under root k by m. So R value 150 divided by under root k. What is the k value? 2 into 10 to the power 6 divided by mass 10 kg. So R value you will be getting something here. That R value I will utilize in this formula. Got it? Vinay, you are getting 0.197. Okay, let me check also. First of all, R value 1.1124. This value I will put here. Okay, so amplitude was 1.9 into 10 to the power minus 3, because we need to convert into meters, equals to F naught 1500 divided by K value 2 into 10 to the power 6 divided by under root 1 minus R. R value is 1.1124 square. Square and whole square after that, plus 2 into damping factor into 1.1124 square. Right, like this we will be solving. So we have to do what? Squaring on both the sides. We need to do the squaring on both the sides. So basically 1 minus 1.1124 square whole square plus 2 into damping factor into 1.1124 whole square. So that part will come on the left side, let's suppose, and all the part will be on the right side. So 1500 divided by 2 into 10 to the power 6, okay, divided by 1.9 into 10 to the power minus 3. Like this. Now we will do the squaring on both the sides and we'll get the answer from here. So what I will do the squaring on both the sides. After doing squaring on both the sides, you can easily get the answer of damping factor. Okay everyone? So remember what we need to do, squaring on both the sides, because on the left side it is the square root, so it will get cancelled out. So you will get the answer of damping factor after that. So just solve this right part. Left part will be 1 minus 1.1124 square, then whole square. So from here damping factor you will be getting. Tell me your answers for this damping factor or damping ratio. Approximately if you solve here, the answer will be 0.1417. So yes, definitely calculation is little bit more, but Question is not that much difficult. So calculation part we need to take care in this question. If you know this formula, amplitude of steady state vibration, then it is very easy. But calculation we have to take care, very important part. So that is the biggest challenge many people are facing. They know the formula, they know the approach, but in the calculation they are doing some mistake. Then the whole effort, okay, the whole time that you have invested in that particular problem will go waste. So that should not happen. So please take care of your calculations part, right? So finally answer for damping factor is 0.1417. 0.1417. Okay. Now we'll move to the next problem, guys. Okay. We'll move to the next problem. Done. So this was your answer finally. 0.1417. Okay, this punching, many people have asked also, like regarding sir punching machine. In the flywheel case, na, how to solve this punching problems in flywheel. Usually in flywheel till now in the gate examination, punching related problems they have not asked. Engineering services, there are so many problems from the punching machine. Okay, so I will give you some little bit information, important relations that we need to remember to solve any punching related problems, right? So actually what happens in punching machine, okay, there is a crank, connecting rod, and here some tool will be connected. Okay, this is the plate T having thickness T. On this plate we need to do the punching operation. On this plate we need to do punching operation, right? Okay, Vinay, yes, approximately 0.14 it will be there. Yes, correct. The answer for the last problem, right? Now actually what happens, now coming back to this punching concept, guys, please remember this concept. Everyone, please focus on this punching concept. So at least some basics you should know, then all the problems related to punching you will be able to solve. So there is some kind of mechanism we are having, okay. This is a crank connecting rod, and on the slider we have this cutting tool. So crank is having complete rotation. This punching tool will be having this 2 stroke, one from this top position to bottom position, then again one more stroke from bottom to top. So it is having 2 stroke for complete rotation of the crank. For complete rotation of the crank, this tool will have 2 strokes. Okay, remember this part. This is what 2 stroke we will have, 2S, right? So it will do punching and then again go back, go towards the down, okay? Below the plate it will come out and then again it will move back. So that is what you need to understand. It start its journey from here, it will go here, in middle it will do punching operation and then again return back. Okay, it will come here, then again come back like this. So that is what the 2 stroke of punching operation. Clear? So this is the tool and it will perform the punching operation on the plate. Now, see what happens here. First of all, cycle time. Total time required, first of all, total time required. Is actually, we call it as cycle time. Okay, and there is one more time which is known as actual time. Actual time means basically the time at which the punching is happening, and apart from that punching, what is happening? Idle motion, idle operation it is there. No useful or nothing, basically we can say, see, punching happens here when it punches the plate. For that only whatever time required is known as actual punching time. Apart from that, all the stroke movement is idle. Nothing we are getting from it. That is why it is known as idle stroke. Actual punching happens here. So for that punching, whatever time is required is known as actual punching time. So that cycle time TC is the total time required. Total time required from here to here, then again from here to here. That is what the cycle time. This tool, punching tool will move from here, then do punching, then it will go down, then again it will move back to its original position. So whatever time required, total time required is known as the cycle time. But there is an actual time for which punching is done for that particular time only. Remaining is what the ideal stroke. Okay, actual time required is represented by TA. Actual time required is represented by TA. Now, very important thing. I hope you got the point from here, starting of this motion to the end of what? The cutting operation. Whatever time required is total time, but punching is happening for this moment only, when the cutting is happening in the plate. So, for complete cycle time, this crank is rotating 360 degree, or I can mention 2 pi as well, right? How much distance is traveled by the tool? Total 2 into stroke, 2s basically. But in actual time, if I talk about actual time, for that whatever the angle turned by the crank for which actual punching is happening, because when tool comes at this position, okay, there will be some theta 1. When tool comes out of this plate after doing the punching operation, crank will have angle theta 2. So the angle actual turned is theta 1 minus theta 2, or theta 2 minus theta 1 basically. So actual angle turned during punching we will be writing here. Let's suppose theta, simply I am mentioning theta. Theta is that particular angle for which actual punching is happening. And how much movement will be there for the tool? Plate thickness. Movement of the tool will be plate thickness. For actual time, the movement of the tool will be 2s, 2 into stroke. For actual time, theta is the angle turned, but for total time or the cycle time, angle turned by the crank is 360 degree. Okay, I hope you are getting this point. Now, so from this we can write directly this ratio, TC by TA equals to 360 degree divided by theta, the angle turned during the actual punching, equals to 2 into stroke divided by the plate thickness T. So this is one of the formulas that you should remember. This is one of the formulas you should remember. Now next, what is delta E? Delta E, that is change in the energy. So it is equals to the energy required per hole minus energy available during punching. Okay, please remember this formula. Everyone, please try to remember this formula. Delta is the fluctuation of energy, which is the difference of energy required per hole minus energy available during punching. Now, energy required per hole, you can calculate using this relation, power of motor multiplied by the actual, basically cycle time, not actual, cycle time. See, motor is what used here to run this machine. Okay, so this is what we need to remember first of all. Energy required per hole is what? Power of a motor multiplied by the cycle time, and energy available during punching is power of motor multiplied by actual time. Difference of this energy is what? The fluctuation of energy. Difference of this energies will be the fluctuation energy. Now, please remember, this is very, very important formulas. This delta E, most of the time this delta E calculation they will be asking. Okay. Most of the time this delta E calculation part they will be asking. Now, one more thing. Cycle time, actual time, it is clear. Apart from that, the angle turned by the crank for the complete cycle is 360, but for actual punching some angle will be there, theta, so that will be given in the question itself. So this is one relation, this is another relation from which you will get the answer very easily. Energy required per hole, there is one more relation that you should also write. It is equals to energy required for cutting multiplied by the shed area. See, it will be 2 pi into d into t, like this. That is what the shed area we will be having. So this is another way of calculating energy required per hole. Another delta E formula that usually we'll be using is IM, that is mass moment of inertia into omega square, average omega, multiplied by CS. This is the main formula. So sometime they will be asking the mass moment of inertia of the flywheel required, or a CS value, or omega value. One of the parameter they will ask. But how to get delta E? This is the formula. Energy required per hole minus energy available during the punching operation. Is it clear? Tell me everyone, is the concept is clear or not? Okay, from this concept you can solve all of the punching related problems from the flywheel chapter. From the flywheel chapter you can solve all of the punching problems, right? Now, let us move to the numerical part. Yes, this is the question for you. So, punching requires 12 kilojoule of energy for punching one hole, and it takes 2 seconds for actual punching. See, actual time they have given 2 seconds. Remember this part. Punching requires 12 kilojoule of energy for punching one hole. So, they have given energy required per hole. Directly this value has been given as 12 kilojoule. Okay, fine. The punch complete 10 holes per minute. Okay, 10 holes per minute. Now, this is very important information, guys. So, this thing can also be written as like this, 10 holes, and if I convert minute into second, 60 will be coming here, which can also be written as 1 by 6. So, one hole will take how much second? Now, 10 hole is taking 1 minute, 10 hole basically 10 hole is taking 1 minute, which is nothing but 60 seconds. So, one hole will take how much seconds? 1 second. This basic mathematics you should be able to understand. Yes or no? 10 holes for 1 minute. Okay, for 1 minute 10 holes will be there. I have converted minute into seconds, which is 60 seconds. So, 10 holes for 60 seconds, which means one hole for 6 seconds. So, the cycle time here, okay, from this information what I actually got, cycle time is 6 seconds. This is the information I got finally. Cycle time is 6 seconds. Done. Now, energy required per hole is 12 kilojoule, cycle time is 6 seconds. Just now I have told you one formula here also. Energy required per hole is nothing but power of motor multiplied by cycle time. This formula I will use to calculate power of motor. So, this is 12 kilojoule, power of motor multiplied by 6. So, power of motor finally we will be getting here as 2 kilowatt. Okay. Now, what actually they are asking, see everyone, fluctuation of energy. Now to calculate fluctuation of energy, the formula is energy required per hole minus energy available during punching. Now energy required per hole already given as 12 kilojoule minus energy available during punching. What is the formula we have written here? Power of motor multiplied by actual time. Actual time is given in the question as 2 seconds only. So power of motor into 2 is the actual time. So finally you will be getting as 8 kilojoule as the answer. 12 minus 4, 8 kilojoule is the final answer for this particular problem. So the formulas that I have written here, from that you can solve any of the punching problems. And definitely this year you can expect one question of live wheel specifically from the punching concept. Right? This is what very important. Now we'll move to the next problem. Yes, this one. Okay. Solve this one, everyone, fast. See, a press has to punch 30 holes per minute. Now, this is very important information. 30 holes per minute. Same information can be written as, because it is minute, so can be converted into seconds. So 30 holes in 60 seconds, which can be written as 1 by 2. So 1 hole in 2 seconds. So this information is telling us cycle time is 2 seconds. Cycle time is 2 seconds. Okay. Motor delivers 1.5 kilowatt. So power of motor is given. If the actual punching of each hole is accomplished during 30 degree of crank rotation, I hope you remember 30 degree of crank rotation. This is the theta for which actual punching happens. Yes, Vinay Kumar, correct. Your answer is correct. 8 kilojoule. I hope you remember. I was telling you regarding the theta. Here I have told you this theta. Theta. What is this theta? It is that theta for which actual punching happens. At this point some theta will be there. At this point some theta will be there. From here to here, how much crank has rotated in the movement of, in the movement of this tool from here to here, how much crank has moved? That theta I have talked about here. So that theta in this question they have given directly as 30 degree. Okay. Fluctuation of speed not to exceed plus minus 10%. Okay. So CS value plus minus 10% they have told. Plus minus means minus 10 to plus 10, which actually becomes 20%. That is 0.2. So determine the minimum moment of inertia. Okay, fine. TC by TA 360 degree for a complete cycle, but for punching how much rotation is there? 30 degree. Cycle time is 2, actual time I need to calculate. So it will be what? You will get easily cancel out this part. This one will be 12. So TA will be 1 by 6. This is the actual time. This is the actual time. Now, in order to calculate mass moment of inertia, I need to calculate what? Delta E. How you will get delta E? What is the formula here? Energy required per hole minus energy available during punching. Okay, which can be written as power of motor multiplied by cycle time minus, here it can be written as power of motor multiplied by actual time. So delta E, power of motor as it is given in the question, 1.5 kilowatt. So 1.5 kilowatt multiplied by the cycle time. Cycle time is 2 seconds minus 1.5 into actual time is 1 by 6. From here delta E value you will be getting. Tell me your answer of delta E. Do the calculation fast, guys, everyone. Delta E value you should tell me fast. Delta E answer. Correct. So in terms of joule, if I have to write 2750 joule, so this value I will be using now. Mass moment of inertia multiplied by omega. Now what is the omega value, omega average? What is the omega average value? Everyone tell me what is the omega average value? Again, this information is not directly given into the question. Directly it is not given in the question. So how you will get to know about the omega average? See, 30 holes per minute. So for cutting one hole, how much rotation the crank will have? How much rotations it will have for one punching? For one hole, for cutting one punch, what is the rotation done by the crank? One rotation? Yes or no? And in a minute, how many holes it is doing? 30 holes. So 30 holes, one hole correspond to one complete rotation of crank. So 30 holes correspond to 30 rotation of the crank. So 30 rotation of crank or 30 revolution of a crank divided by minute, per minute basically. So it is nothing but the 30 RPM. It is nothing but the 30 RPM. So omega will be calculated as 2 pi n by 60. So 2 pi into n, that is 30 divided by 60. See, 30 holes we are performing in 1 minute. 30 holes corresponds to what? 30 revolutions in 1 minute. So I can say na RPM is what? 30. Correct. So that's what we need to interpret the data. Okay. We need to understand what 30 holes in 1 minute is telling. What is the importance of this information and what interpretations we can draw. So that is 30 RPM. So omega will be written as 2 pi into n, that is 30 divided by 60 square into CS, that is 0.2. Now from here you will get the answer. Of mass moment of inertia. You will get the answer of mass moment of inertia from here very easily. Mass moment of inertia value you will be getting. Tell me your answer. .14 correct here, that is omega value. So mass moment of inertia you can cross check 1394.5 kg meter square. 1394. 5.5 kg meter square. Approximately like that only you will get the answer. Correct, Vinay? Now we'll move to the next part here. Next question. Yes, again a very small question I would say, but very important information is what required here to solve this question. Very small question, but concept is what very important here. See, in reciprocating masses, I hope you remember the point, like it is not completely balanced. Okay, we cannot do complete balancing of reciprocating masses, right? So we will prefer the partial balancing. So whatever the unbalanced force we will have perpendicular to the line of stroke, the maximum value of that unbalanced force perpendicular to line of stroke will be called as hammer blow. So for a safe design, that hammer blow value, okay, that hammer blow value should be less compared to the weight of the, or basically the pressure applied by the your vehicle or the rail basically. Okay, so now in this question what they are having, they are giving in the question, the balancing of a reciprocating train engine balance mass of 80 kg is placed at a radius of 100 mm. If the pressure on the rail in the downward direction is 200, then the permissible value of angular speed. So understand, the pressure on the rail in the downward direction is 200. So that 200 is the maximum value, because hammer blow in the vertical direction, if it is applying more than 200, so what will happen? What will happen? If this is what the 200 Newton pressure applied by the rail, but this hammer blow value is greater than 200, tell me what will be your answer? So basically this hammer blow, remember this part, for safe condition, what I will write here, okay, permissible, basically they are asking permissible value, so I should write here like permissible, for permissible value of angular speed your hammer blow should be equals to 200 Newton, which is what given in the question, right? Hammer blow, how you will write hammer blow? It will be MBRB omega square, its maximum value, so MBRB omega square we will write simply equals to 200. So from here omega answer we need to calculate, simple. Omega answer we need to calculate simply. So MBRB omega square into sin theta it will be there, but for maximum value sin theta should be 1. So MBRB omega square I am writing here. Okay. So your answer for omega, this is 80, they have given radius 0.1 into omega square equals to 200. What is the final answer? Answer of omega here. What will be your answer for the omega? 5 radian, na? It's very simple calculation. You should be getting 5. Right? So hammer blow in ideal condition, hammer blow should be having a less value compared to the pressure that rail is what applying. Correct? So that information you should be having at least. Done everyone? Vinay, it will be 5, not 15. It will be 5. How it will be 15? It will be 5, na? Correct, correct. Okay. Next question. Yes, this part. Again, from the balancing only. Calculation is very, very important. Even if we know the concept, we know the formula, everything we have like done correct here. But in the last step, we have done the wrong calculation mistake. So that is what the problem. Okay. You will be wasting all of your hard work. A small single calculation mistake will waste your hard work, whatever you have done so far for your GATE examination. So please be careful while doing the calculation part. Don't do simple silly mistakes. Now, this question. It is proposed to balance 50% of the reciprocating masses in a single cylinder reciprocating engine which is rotating at 150 rpm. Okay. The masses of revolving and the reciprocating parts are 30 kg acting at the crank radius and 40 kg respectively. Fine. If the stroke is 350 mm, okay, so this thing you should know, I think. Stroke will be twice of crank radius. So crank radius you will be getting half of stroke, that is 175. Because stroke is 350, so half of 350, 175. The balance mass required at a radius of 320 mm. Now, see, simple, this formula you should remember. MBRB equals to C into M into R. M is what? Reciprocating. Right? And plus reciprocating mass here plus mass of rotating mass multiplied by the radius at which it is placed. Simple. This formula will tell you how much balancing mass is required. Now, what is C? C is your how much balancing you are doing, how much percentage of balancing is required. So that's what we always say, na, partial balancing of reciprocating engines. So how much partial you are talking about? In the question itself, they have given 50%. So we'll be writing the value. Okay, balancing mass required at 320 mm. So we will write MB into 0.32, 0.5 into reciprocating mass in the question. They have given us 40 kg into at what radius? Crank radius. So 0.175. kg, 0.175. From here, balancing mass, you will get the answer. Tell me what is the balancing mass answer. Tell me your answer for the balancing mass. Everyone. Balancing mass answer will be simple calculation, it is there, na? So you can easily tell me. Then balancing force required at a crank position of 45 degree, then this part we need to calculate. Vinay, tell me your answer for this balancing mass required. It will be what? Approximately 27. Yes, correct. Approximately like this you will get the answer. Correct, Vinay. Yes, absolutely. Now, unbalanced force at the crank position 45 degree from the dead center. Okay. There are two unbalanced forces. So, I will suggest you directly remember the formula. Okay. A long line of stroke 1 minus C mr omega square cos theta. Theta 45 already they have given. Perpendicular to line of stroke. It will be C into mr omega square sin theta. Now, one thing you should understand, one basic point I will tell you to save time. Okay, so you have to be little bit smart to save time also. 1 minus C value is what? SC value is 0.5, 1 minus C will also be 0.5. So this value will remain same. So once you have calculated this value automatically have the same value whatever it is having. So 1 minus 0.5. Okay, what is the rotating mass they have given? Okay, not rotating, this reciprocating mass 40, sorry, this is 40 into 0.175 into omega square. What is omega value? RPM they have given, I think, yes, 150, so 2 pi in cos 45. So you need to just calculate this value only, because anyhow this value will also be the perpendicular to line of stroke, unbalanced force perpendicular to line of stroke. This value and this values are same only, because C 0.5, 1 minus 0.5 remains same. Okay, do it everyone fast. And the resultant unbalanced force along line of stroke you will get the resultant answer also from this relation. Do it fast. What will be your answer for the unbalanced force along the line of stroke? Approximately it is coming 610. Just cross check your answers as well. Vinay, 610.03 approximately 0.0316 Newton. This value will remain same, and finally you will do the square of both the values, then under root. You will get the resultant. Yes, correct. 610. Yes, approximately, yes, same answer you are getting, correct. And finally, if you calculate resultant unbalanced force, it will be 862. Nearby to 862 value it will be there, 862.7. So this calculation I have already done, 862.7 approximately. Right? So please be careful whenever they are asking a NET numerical answer type question, they will say up to 1 decimal place, up to 2 or up to 3 decimal place also. So we have to be very careful regarding the calculation part. And one small suggestion from my side, guys, whenever you are solving a numerical, don't try to do the approximation in the initial steps. In the initial steps, you should not be doing any approximation. Reason, if I do the approximation in the initial steps itself, the final answer will be varying from the actual answer. Okay, there will be huge difference of the actual answer and your answer that you are getting, because you have done the approximations in the initial steps. So please try to avoid the approximations in the initial steps. You can do the approximation in the final step, that's fine. But if I have done the approximation in the initial steps only, it will affect my whole calculation and my final answer will be having a huge difference as compared to the actual answer. So please try to avoid initial approximations in the initial part of the calculation. Right? So this is the final answer. Right? So I hope like whatever questions we have solved today you have enjoyed, and please these questions you have to revise it again. Okay? So that is what we need in this particular time. Important questions we need to solve, important PYQ we need to solve, and please revise your formula sheets that you have created so far in all the subjects. Revise your formulas and relations through your formula sheets. Revise your PYQ and important questions. Okay. Yes, Vinay, correct. Approximately correct. Your answer is also correct. So please remember, in the revision we need to solve numericals. I've seen many people are simply reading only. Please try to solve numerical. Okay, numericals, which numericals you need to solve? Important one, important PYQ questions or important questions that we have done in the YouTube sessions, or important questions you have find in your mock test also. Those important questions you need to solve. At least daily for every subject you should solve some questions. That's how we will do revision. So let's suppose 10 subjects we have. For all 10 subjects we need to solve daily some questions from all the subjects. Right? So that's all from my side, guys, and thank you so much for attending the session, and all the best for your GATE 2024 examination. And whatever you have done till now, whatever preparation you have done, you will get the best result out of it. Thank you so much. Thank you so much. Bye bye. Vinay, next classes you will be having for this thermal part also. So you please stay tuned to the IMS GATE Academy channel, YouTube channel. You will get to know all the details, right? For the upcoming classes, you can stay tuned on the YouTube channel.